So today, all you guys are going to do is I'm going to go over how to do each type of problem on your worksheet. Okay, basically I'm going to do the first one, and then for homework, you guys are going to do like the next two. Okay, so there's 4 different types of problems on this worksheet. So like I said, I'm going to do the first one, and then you guys are going to have 2 for homework. I'm going to do the first one, and then you're going to have 2 for homework, and then we're going to do the same thing on the back. So to start with, let me zoom for you, sorry. Okay, to start with, we are trying to figure out what is the solution to this equation. So obviously there's lots of fractions here. We do not like to work with fractions. So first thing we have to look at is how do I eliminate the fractions here. So I want you to look at the denominators. Okay, if you look at the denominators, I have a 5, a 6, and a 3. Okay, first thing you want to look for is what is the biggest number. Okay, and in this one it's a 6. If I multiplied everything by the biggest number, would it cancel out all the bottoms? Not quite. Okay, it would cancel, if I multiplied everything by 6, it would cancel out the 6 and cancel out the 3, but not the 5. So this is when you want to look at the 2 largest ones and multiply them together and multiply by that. So the 2 biggest ones are 5 and 6. What's 5 and 6 multiplied together? 30. 30. We're going to multiply every single part of this equation by 30. Okay, and I know that sometimes that means we're going to multiply by large numbers, but it's going to get rid of our fractions, and that's what we want. So here, we're going to multiply every single part by 30. I recommend putting the 30 next to every single part, okay, on purpose. Then I actually want to do my reducing. So here, 30 and 5 reduces to be what? Zoom this in more for you. So yes, these reduce and leave you a 6. 30 and 6 reduce and leave you what? A 5. And 3 and 30 reduce and leave you a what? A 10. Then we actually multiply. So don't lose these negatives. Be careful if there's ever a negative. So negative times 6 times 4 times x. What does that give you? 6 times 4 is what? 24. We know I had a negative. And there's an x. So negative 24x. Then 5 times 1 is what? Plus 5. You have to put the plus. And equals 2 times 10 is 20. How would I solve from there? So now that I've eliminated my eliminated the fractions, what would I do next? Move the 5, right? So subtract the 5. Okay, if you subtract the 5, that leaves us with negative 24x equals 20 minus 5 is 15. And then how do I move the negative 24? Oops, sorry. How is the 24 attached to the x? By add, subtract, multiply, or divide? By division, or by multiplication, excuse me. So to get rid of that, divide it on both sides. So these go away. We get x equals, can 15 over negative 24 reduce at all? Does anything go into both 15 and 24? 3. Okay, if you divide by 3, what do you get on the top? A 5 over, what's 24 divided by 3? 8, and there's still a negative with it. That's your answer. Negative 5 over 8.
Did we change it to a decimal?
I do not want you to change them to decimals, no. We're going to leave these in fractions. Basically, if your problem starts in fractions, whatever your problem starts in, that's what you want your answer to be in. So since this one started in fractions, I want to leave it in fractions at the end. Okay? You guys are going to be able to do 2 and 3 for homework. Okay, now I'm going to look at number 4. What is the solution to this equation? We did these kind of at the beginning of our unit. Okay? Does anyone remember what's the first thing you want to do here? Anyone remember? Yeah, Eric? Change the mixed number to be an improper fraction. Okay? How do I change 2 and 1/3 to be an improper fraction? Right, we multiply the whole number in the denominator and then add the top. Okay, so 2 times 3 gives you what? 6 plus 1 is 7. So I'm going to rewrite this as 7 over 3. So I'm just going to rewrite my whole problem. So 3/4 x equals 7/3. From there, how do you get rid of something attached to a fraction? Use the, say it again? Use the multiplicative inverse. And what is the multiplicative inverse here? 4/3, which is basically the reciprocal. Okay, so multiply by the multiplicative inverse. So flip this, multiply on both sides. These will eliminate. So these go away and we get x by itself equals, can anything eliminate here? Can these 3's cancel each other out? No, because they're both on the bottom. Okay, if one's in the numerator and the denominator, they cancel each other out. But this one does not cancel anywhere. So what do I do when I have two fractions next to each other? How do you multiply fractions? Multiply the tops, multiply the bottoms. So 7 times 4 gives you 28 over what? 9. Now, I am okay with you leaving your answer like this. But what if it's a multiple choice problem and they're all switched to mixed numbers? What is that equivalent to in mixed numbers? How do you change it to a mixed number? Turn on its side and divide, right? So you need to be able to do both, okay? I'm okay with leaving it as improper fractions, but I want to make sure that you can change it to a mixed number if you need to. So turn on its side and divide the 9 into 28. How many times does 9 go into 28? 3 times. 3 times 9 is 27, so you have a remainder of what? 1 over 9. So I would be okay with 28 over 9 or 3 and 1/9. Okay, those are equivalent to each other. I am okay with the improper fractions, but on your test, sometimes, depending upon, if the test wants it, sometimes they'll give you improper fractions, sometimes they'll give you mixed numbers. So I just want you to be able to change them if you have to. Anyone have questions so far? No, good. Okay, let's look at the back. Let's look at number 7. Okay, it says solve this equation. What does that mean when you have a number on the outside of parentheses? What do you have to do? Distribute, right. So multiply to everything inside the parentheses. What's 2.5 times x? 2.5x. 2.5x plus 2.5 times 7. Do that on like the side of your paper if you need to. So do 2.5 times 7. You do it and then hopefully we'll get the same answer. What do we got? Oh, what did I do wrong here? The decimal point, okay? So yes, I did the multiplication right, but don't forget that you have to put one decimal place there. So 2.5x plus 17.5 equals -5. What would I move?
The 15 or 17.
Move the 17.5?
Yes.
So subtract 17.5 minus 17.5. Okay, so I still have 2.5x equals, what happens if you have the same signs? Add them, keep the sign, make sure that you line up your decimal point if you need to, so there's like a 0.0 here. So add these together. That gives us -22.5. And then how do I get the x by itself? Divide both sides by 2.5. So divide both sides by 2.5. You might have to do a little bit of long division here. So 2.5 into 22.5. What do I have to do before I can start that division? Move the decimal. How many places am I moving it? Just one. Okay, so put the decimal up there if you need to. How many times are 25 going to 22? Doesn't. How about 25 into 225? Yeah, it's not 18. What do we say? 9. Okay, and does that work out evenly? Perfectly? Think of quarters. Okay. How many quarters would you have? Like 25 cents. How many quarters would you have if you had $2.25? Okay. Think of them that way. Like count them on your fingers and toes if you need to. So 9. So x equals 9. And now I'm done. So all that work for a 9. But that's okay. And then the last one I'd like to go over with you guys is number 10. Okay, what is the solution to this equation? Where would you begin that problem? Distribute. So distribute the 6. And distribute this 2. Make sure that you're only distributing to the parentheses. Okay, so you have two different sides going here. So 6 times x is 6x plus 6 times 2 is 12 equals 2 times 3x is 6x plus 2. Do you guys remember these equations a little bit? Kind of, sort of, maybe? Where do you start? Where do you go from here? Combine the like terms, so what would you move? The 6x. Doesn't really matter which one you're moving because they're both the same. So they eliminate. So we got 12 equals 2. Will 12 ever equal 2? No. So what does that mean? No solution. Good job. Okay, that's a special case of no solution. What that basically means is does not matter. You could plug in every single number you wanted to for x, and it's never going to work out, ever. Okay, this is like an impossible problem. No solution. So what you guys are going to do is for homework, or actually for the rest of class time today, I would like you working on completing this worksheet. Okay, so you only have 8 problems to do. I forgot that I was